Hello everyone, welcome to my channel Vidyarthini's Academy of Computer Science, Learn with Passion. In today's video lecture, we'll be learning about process management. Under process management, we will be seeing about process states and process control block PCB. And both these topics are very important from exam point of view. That is, in almost all the semester exams, these questions come either in 2 marks or 5 marks or 10 marks, or even or if you see in some question papers, these questions come in all the sections, that is in 2 marks, 5 marks and 10 marks, all the sections it's been asked. So this is a very important topic. And before we get started, if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. Let's get started. Process management. Under this, we'll be first seeing about what is process and what is a program. First, we will try to understand what is a process and what is a process. We have seen this definition in a previous video also. Process is nothing but a program in execution. So process is a program which is in the execution state. So a process is defined as an entity which represents the basic unit of work to be implemented in the system. So it is the basic entity which is to be implemented in the system, whereas a program is a static entity made up of program statement, while process is a dynamic entity. So program is a static entity, whereas a process is a dynamic entity, because a process will be first in one state, that is beginning, then it will be in ready state. So we'll be seeing about the state of the process in the next slide. So process keeps changing. So it is a program in execution, whereas a program is a static entity. So process is a dynamic entity. Program contains the instruction to be executed by the process. So program will be nothing but a program statements which has to be executed by the process. So program contains the instructions to be executed by the process. So this is the state diagram. This is a very important diagram. So when they ask you to explain about process state, they will or a state diagram of a process, you have to draw this diagram and explain about this topic. So initially the process will be in the new state, and once the process is admitted, it will be in the ready state, and it is ready to get executed. And once it has been scheduled, it will be in the running state, and it will be in execution. And when there is an interrupt, that is interrupt might be for example be caused by either a higher priority process, so that until that process is completed, this current process has to be in the ready state. And when the control comes again to this process, it will be in the running state again. And there might be some IO operations, like IO operations, in the sense either the process might be requiring some input from the user, or the process might be giving output to the user. So during that process, during that event, this process will be in the wait state. And once the IO operation is completed, it will again go to the ready state, and it will go to the running state, and it will be executing. So once all the work of the process is completed, it will go to the terminated state, and the process will be completed. So this is the state diagram of the process. So let us see in detail. As a process execute, it changes the state of it. That is a process. So that is why we call this process as a dynamic entity. So once the process is running, its state changes. The state of the process is defined in part by the current activity of the process. Currently, what activity the process is doing, either it is in new state, or it is ready for execution, or it is in running state, or it is just because of IO operation, it is in a waiting state, or the work of the process is over, so it is in terminated state. So the state of the process is defined in part by the current activity. What activity the process is doing, depending upon that, the state of the process is defined. So each process may be in one of the following state. All the process will be in either one of the state. So it will be either in new state, that is process is being created, or in ready state where the process is waiting to run, waiting to get executed, or in the running state. In the running state, that is the instructions are getting executed, instructions are being executed. Then the waiting state. In the waiting state, the process is waiting for some event to occur, either IO event, that is either it has to get the information or it has to display some information, like that. And once all the work is over, the process is in the terminated state. The process has finished execution completely. So this is the state diagram of the process. You have to, when this question comes, you have to draw the diagram and give the explanation about each state. So if it is coming in 5-mark question with the diagram, you have to give the explanation. You will be getting the 5 marks. Okay. The next topic is the process control block, and even this is an important topic. This will be asked in either 5 marks, or it will be combined and asked in a 10-mark question. So you have to draw this diagram and explain about each and everything. So this is one of the important topic from the semester point of view. Yes, PCB contains the pointer, process state, program process number, program counter, register, memory limits, list of open files. So what is this PCB? A process in an operating system is represented as a data structure known as process control block, PCB. It is also called as process descriptor, or it is also called as task control block. Alright, the PCB contain important information about the specific process. So it contains the important information about a specific process, and what are the important information? It will have, the first thing is the process state. So we saw about the process state diagram, right? So in what state the process is currently in, that information will be stored under process state. So the current state of the process, that is whether it is a new, ready, running, waiting, halted, and so on. This information will be stored in the process state. So next is the program counter. So what is the program counter? It includes the address of the next instruction to be executed for this process. So what is the next instruction that has to be executed? That details will be stored under program counter. So third one is the CPU register. So here the register vary in number and type depending on the computer architecture. They include accumulator, index register, stack pointer, and general purpose register, plus any condition code information. Along with the program counter, this state information must be saved. So in program counter, what we saved? We saved the information about the next instruction to be executed. Same way, in CPU register, these details must also be saved, and it is also needed. So when an interrupt occurs, to allow the process to continue correctly afterwards. So this why we require the CPU register. So program counter is needed so that we will know about the next instruction to be executed. Same way, this CPU register, details in this CPU register is important in order to tell the process what it has to do when an interrupt occur. So this we will understand about the CPU register by seeing the next diagram. So in this diagram there are two processes, P0 and P1. So process 0 is getting executed and in between is the operating system function, and let's see what is happening in this diagram. So process 0 is getting executed, and when it is getting executed there is an interrupt or the system call. So what will happen, the state of the PCB 0, that is each process will have its own process control block. Here you can see the note, only one PCB is active at a time. So the process control block of the process 0 will save the state of the process 0, and it will be and PCB 1, that is process 1's PCB will be reloading, that is it will be getting ready to execute. So the process 1 will be getting executed. The P0 will be interrupted and the state of it will be saved in the PCB 0, and the state of the PCB 1 will be reloaded, and the process 1 will be getting executed. And when the execution is done and there is an interrupt or after the P1 is completed, the state of the P1 will be saved in PCB 1, that is PCB process control block of process 1. The state of the process 1 will be saved, and PCB 0 will be reloaded, and process 0 will be executed. So that is till when an interrupt occur, the process 0 will be in idle state, and when once it starts executing, it will be in the execution state. So this diagram shows the CPU switch from process to process. So when that is program counter has the instruction about information about the next instruction to be executed, whereas the CPU that is CPU register will have the information about the this information, that is when that is when an interrupt occur, it will save the state of the process, and when it has to get reloaded, this information will be saved in the CPU register. All right. So the important thing to be noted here is that only one PCB is active at a time. All right. So next is the CPU scheduling information. CPU scheduling is another important topic which we will be seeing in the upcoming slides. For now, you have to know about what is stored under CPU scheduling information. It includes information about the process priority. As I said, depending upon the priority, the process scheduling will be done, and so the information about the process priority will be stored here, and the pointer to the scheduling queue will be stored here, and any other scheduling parameters will be stored in this place. Okay, the next is the memory management information. This information may include such information as the value of the base and the limit register, the page table, or the segment table, depending on the memory system used by the operating system. So what is base and limit register, what is the page table, what is segment table, all this we will be learning in the upcoming chapters. For now, what is there in the memory management information? It is having information about the base and limit register, the page table, or the segment table, depending upon the memory system used by the operating system. All right. Next is the accounting information. Under this you have information about account of a CPU and real-time used, time limit, account numbers, job or process number, and so on. All right. So next is the IO status information. This information include a list of IO devices allocated to the process, a list of open files and so on. So it contains details about the IO devices related to this particular process. Okay, in short, what we can say about PCB. PCB is simply serves as the repository for any information that may vary from process to process. So it serves as a repository for each and every process. All right. So with this, PCB is completed. Okay. Next, we'll be seeing about the questions asked in the semester questions, semester exams. So these are the clippings from different semester exams and how they have asked this topic, PCB and process state. Okay. This is a clip from November to December 2016 question paper, wherein explain states of process with need diagram has been asked under 5 mark in section B, and PCB in the same year PCB is asked under section D, which comes under 10 mark, 10, that is part A, part B, that is the question, the 10 mark is being divided for A and B. So for A PCB it will be it is for 5 marks. All right. This is November December 2019 question paper. Here define a process is asked under 2 marks, and explain the process with a need diagram. Explain the process state with a need diagram. It's been asked under B section for 5 marks. And in the same question paper, the process control block is asked for under section D, which is again a 10 mark question. Part A, that is it, the value of PCB under 10 marks is 5 marks. So process control block and process state are very important topic from semester exam point of view. If you have any doubts regarding this topic, please do comment below. I'll surely answer your questions regarding the subject topics. And my next session is about process scheduling. And thank you. If you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. Thank you. See you in the next lecture.